So the discrete random variable x is given by the probability x equals x is kx, and x is from 1, 3, 5 and 7. So first job here is to make the distribution table. So x can be 1, 3, 5 or 7, and the probability that x equals x is kx, so it's k times its x value. So if x is 1, probability is k times 1, which is k. When x is 3, it's going to be k times 3, which is 3k. K times 5 is 5k. And when x is 7, k times 7 is 7k. So that's the distribution table. Now then, I want to show that the value of k is 1/16. Now you've got to be careful here. You put all the detail in when working this out, because we got the answer, and I need to make sure that I put all the workings down in detail. So I know that the bottom line totals 1. So because it's a discrete random variable and it's a probability distribution, then the bottom line totals 1. So I know that k plus 3k plus 5k plus 7k is total 1. Adding these k's up, 4k, 9k, 16k is equal to 1. So k is the value of 1 shared by 16. Part B, I want e of x. So to work out e of x will be the x value times its probability plus the x value times its probability, and so on. So it's going to be 1 times k, I'll substitute for k at the end, plus 3 times 3k plus 5 times 5k plus 7 times 7k, which is k plus 3 3s are 9, so that's 9k, 5 5 is 25k, 7 7s are 49, so that's 49k. And adding those up, that's 1 plus 9 plus 25 plus 49, and that's equal to 84, so that's 84k. And I know k is a value of 1/16, so that's 84 times 1/16. Give me 5.25. First part, and the second part was e of 1 over x. So e of 1 over x. So I have 1 over the x value times its probability. So I got 1 over 1 times k. Again, I'll substitute for k at the end. 1 over the x values, that's 1 over 3 times 3k plus 1 over 5 times 5k plus 1 over 7 times 7k. So first bracket, that's 1k, so that's k. A third of 3 is 1, so that's also k. A fifth of 5 is 1, so that's also k. And a seventh of 7 is 1, so that's also k. So that equals 4k. And k is a 16th, so that's 4 times 1 over 16, which is a quarter. Okay, part C. and given that x1 and x2 are two independent values of x, determine the probability that the sum of x1 and x2 makes 6. So I got two of these tables, one representing x1 and one representing x2. So the x values are the same in each one, 1, 3, 5 and 7. And the probability that x1 is equal to x, again these are the values, k here, k is 16, so I put them in on this, make the table fresher. So that's 1/16, 3/16, 5/16, 7/16. And again my second table for x2, x be 1, 3, 5 or 7. And the probability that x2 is equal to x, again same values, 1/16, 3/16, 5/16 and 7/16. And the first part is asking me to find the probability that the sum of x1 and x2 is equal to 6. So I have to take an x value from x1, an x value from x2, and they have to combine to add up to make 6. So if I take 1 here from x1, I can add a 5 with it. So the first one is the probability of 1 and 5, or if I take the 3, I can go 3 and 3, or if I take this 5, I can take that 1. And those are the ways in which I can get them to add up to make 6. A little bit. So 1 is 1/16, and I'm times in, so we have 5 here is 5/16, or add a 3 here is 3/16, and a 3 here is 3/16, or I add, then a 5 from the first one is 5/16 times, and a 1 in the second one is 1/16. So multiplying those out, so 1/16 times 5/16 is 5/256, plus the second one, now I got bottom number, to this one, 3 3s are 9/256, and the last one will be 5 times 1, that's 5/256. And adding those up, 5, 5 is 10, and 9 is 19, so that's going to be 19/256. Okay, so the last part is I want the probability that x1 is equal to x2. And then, so I could take an x value from the first table and an x value from the second table, and they have to be equal. So that can occur by doing 1 from the first and 1 from the second, or 3 from the first and a 3 from the second, or a 5 from the first and a 5 from the second, or a 7 in the first and a 7 in the second. So a 1/16 times 1/16, or add, for a 3 and a 3, so that's 3/16 times 3/16, 4. Add again, 5/16 times 5/16, 4. 7/16 and 7/16. Multiplying those out, so the first one, top line 1 times 1 is 1, and 16 times 16 is 256, plus 3 3s are 9 over 256, 5 5s are 25 over 256, 7 7s are 49 over 256. And adding those up, so that there's the top line there, it's 49, add 25, add 9, add 1, so that's 84 over 256, and just cancel it down to get the lowest fraction. 256 equals 21 over 64.